Okay, question 13 or 14, your first numeric response says how many grams of Fe2O3 are formed when 16.7 grams of iron reacts completely with oxygen? Round your answer to 2 decimal places. Okay, well, first of all, it tells us that we have to balance our equation. I'm not going to go through that, but once you balance it, you should have a coefficient of 4, 3, and 2. So a 4:3:2 ratio in this problem. Okay, next, take what I'm given, so 16.7 grams of iron, okay, and I want to know how many grams of Fe2O2. So start with what I'm given, 16.7 grams of Fe, okay, and I want to know, again, I'm going to go to grams, so this is going to be kind of a long conversion. So in order to get this from grams to moles of another substance, I'm going to have to put 1 mole of Fe, I know, is equal to its molar mass, which is 55.845 grams of Fe. Okay, so grams would cancel, leaves me with moles of Fe, but I want moles of Fe2O3. Okay, so I've got to continue on. So now that I'm in moles, in order to get to that new substance, I can set up a mole ratio now. So moles of Fe will go on the bottom because it's what I was given. What I want to find is how many moles of Fe2O3 there are. Okay, so if I look at my equation, I have 4 moles of Fe, and of Fe2O3, I have 2 moles because there's a coefficient of 2. So now that cancels moles of Fe, moles of Fe. It puts me in moles of Fe2O3, but I'm not quite finished because it asked me for grams. So to go from moles to grams, again, it's kind of the opposite of this. I know that 1 mole of Fe2O3 is equal to its molar mass. So if I find the molar mass of Fe2O3, it's 159.687 grams Fe2O3. So cancels out moles, leaves me with grams of Fe2O3, which is exactly what I want to find. And if I plug this in, again, some of you have problems kind of calculating it. Instead of calculating in pieces, just do it all at the end. I like to put it in parentheses. Do 16.7 times 1 times 2 times 159.687. Okay, so those are all my numbers from the top. Close the parentheses, divide by, okay, everything from the bottom. So 55.845 times 4 times 1, close the parentheses. Okay, so that gives me 23.87655. Okay, so told me to round to 2 decimal places. So 23.87, and I'm gonna look at this 6, so it gives me about 23.88. So if I were to 23.88 grams of Fe2O3. Okay, so number 15, chlorine is produced by the reaction of 2 HCl yielding 1 H2 plus 1 Cl2. How many grams of HCl must be used to produce 10 liters of chlorine at STP? Round your answer to 1 decimal place. So what I need to do is, again, how many grams of HCl? So how many grams of HCl? That's what I'm looking for. Must be used to produce 10 liters of chlorine. So I'm given 10 liters of chlorine, so that's what I start with. Of Cl, and in the problem it's Cl2. So I've got to put Cl2. Okay. All right. So I'm going from liters to grams. So I'm going to have to convert liters. I can't go straight to grams, so I've got to go to moles first. So I know that 1 mole of Cl2 will occupy 22.4 liters of space. Okay, so that gives me liters, and liters cancel, gives me moles of Cl2, but I'm wanting to find grams of HCl. So now that I'm in moles, I can set up a mole ratio. So what I want to find is HCl, and I'm getting out of CO2 or Cl2. So according to my equation, I have 2 moles of HCl, okay, and I only have 1 mole of Cl2. Okay, so 1 mole of Cl2, Cl2 cancel, leaves me with moles of HCl. So now I'm in the compound that I want, but again, I don't want moles, I want grams. So in order to go from moles to grams, we know we're going to have to use molar mass. So the molar mass of HCl, okay, if you look at a periodic table, add up the atomic masses, is like 36.461 grams of HCl, okay? And we know that the molar mass is equal to 1 mole of HCl. So moles of HCl cancel, leaves me with the units of grams of HCl, which is exactly what I want to find from the problem. And then I'm just going to plug this into a calculator, okay, just like I've shown you in the past examples, and it'll give you 32.554. Now it says round to 1 decimal place. So here's 1 decimal place. I look to the right, that's a 5. So that other 5 kicks up to a 6. So it should be 32.6 grams of HCl. And last problem on the test. For the reaction, how many moles of carbon dioxide are produced from combustion of 100 grams of methane? Round your answer to 2 decimal places. Okay, so underline what was given to me, 100 grams of CH4. Okay, I want to know how many moles of CO2. Okay, so I'm going to start with what I'm given. So 100 grams CH4. Okay, I'm trying to get to moles. So first thing I've got to do is I've got to convert from grams to moles. Well, we know to do that 1 mole of CH4 is equal to the molar mass of CH4. So if I look at a periodic table, add up the atomic masses of each of those elements, it should give me 16.04 grams is the molar mass. Okay, so that cancels grams. Grams puts me in moles, okay, but I don't want moles of CH4, I want moles of CO2. Okay, so CO2 is going to go on top, CH4 is on the bottom, so I can cancel out those units. So CO2, according to my equation, has 1 mole. Okay, and CH4 has 1 mole. Okay, so CH4 would cancel. the units that I'm left with in my conversions is moles of CO2, which is exactly what I want here, moles of CO2. So when I multiply the top and divide by the bottom by putting it in a calculator, it should give me, let's see, let's do 100, okay, because it's times 1 on the top. It's just 100 divided by everything on the bottom, which is just 16.04. Okay, that gives me 6.234. It tells me to round to 2 decimal places, so 6.23 should be your final answer. 23, and that was moles of CO2.